Well, hello, folks. It's Rick Slade again with Compuware. It's good to have you. It's our second live Q&A. I appreciate you joining us. Hopefully this will be educational and useful in the work that you're doing, and we appreciate you joining us. With a little housekeeping before we get started. To ask questions, there's we're going to use the chat box to provide that opportunity. At the bottom of the WebEx, there's a little round box with a chat logo in it. You can click on that to open up the chat box. Should be on the right side, and then in there you can ask questions regarding topic of the day or just about anything regarding software delivery. And so again, we do appreciate your time. Let me kick this off today by sharing a document that talks about the first two sessions. In session one, on the first podcast, we talked about the key characteristics of a software delivery system. And I won't go through those today. Hopefully you were able to see that or hear that. But those things were critical. And then in this week's podcast, David Rizzo and I spent some time talking about the architecture leveraged to support these key characteristics and the importance of that. What you see here is essentially the tool chain we use at Compuware to deliver software for our particular products that we eventually deliver to you guys. And David mentioned a lot of these products last week. You can see that from an ideation standpoint, we are an Atlassian shop. We use Confluence to gather information, to discuss topics of interest, to create a repository or an inventory of demand. And that demand comes from you, our customers. It comes from our employees, from management, lots of different places. But it's where that information is typically discussed, and at some point in time, decisions are made regarding what we're going to focus on, what we're going to work on. Once that's in place or those decisions have been made, we use Jira to actually manage the execution of that work with our different project teams. In that first layer, near the top, defines the IDE for our developers. And as you know, we develop code that's running on multiple platforms, the mainframe and from an x86 perspective, web servers. And so we have worked very hard to provide an IDE to our developers, and I think it's one of the critical to-dos for organizations who are looking to converge and to modernize software delivery into truly a converged platform for developers, where the result of their work from a platform standpoint can be agnostic. But the navigational feel of developing code, the interfaces used to make edits, to do testing, I think if we can create an environment that looks and feels the same regardless of target, then that is a huge business benefit in giving organizations the ability to move resources around. Now, easier said than done. I truly understand that. But providing a common look and feel will allow that developer who may be doing Java work to begin to transition onto modifications or changes into mainframe code. And the more we can build an environment that looks the same, that operates essentially the same, then the easier, the faster, and less costly we can transition as developers from project to project. And I think that's important. We are a Jenkins shop. As I said, automation is absolutely key to a modern software delivery environment. And so Jenkins is our CI server. You can see we use Get through Bitbucket and ISPW, our mainframe software configuration management system, for managing our source and our builds and our deploys, all integrated with Jenkins. SonarQube is a product that we use to provide dashboards and to build quality gates in order to ensure that code is working properly. And then we've got several testing tools depending on the product and the application and the testing requirements that we leverage, mainframe and non-mainframe. Our deploy tools, as well as a code coverage tool that we use for Java and for our mainframe code. And that's been incredibly beneficial to the organization, not from just making sure that you're getting good code coverage in your testing, but to help us in the definition of what that testing environment looks like. We'll talk about this in a later episode, but building a test environment and using what is necessary to provide a quality test is critical. And in a lot of the testing today, I see many shops where it's just essentially a production drop of their production data, and that's what's used, and that can create all kinds of problems, primarily with regard to the amount of time required to stand up and provision that type of environment, and let alone the testing that actually occurs. So we've gotten much more efficient through the use of code coverage metrics in the definition and the building of our testing environments. But we'll get into that at a later date. And then our deploy capabilities, we can deploy to the appropriate next step environment, depending on where we are in the SDLC. The one last thing before we start answering questions that I wanted to share in this particular chart, and it's the most important icon or graphic in the chart, and I wonder what most of you would say is the most critical piece of this architecture that you're seeing here. Well, in my mind, and again, we can have discussions and even arguments about this, but in my mind, it's not any of the boxes, it's the lines between the different activities within that software delivery lifecycle. And it can be overlooked, but those lines represent the interactivity communication automation that's occurring to ensure or to execute this work. And so the ability to automate with technology the execution of this work it will be the biggest or provide the biggest benefit that you can create or produce in evolving your software delivery system. So I just wanted to make that point before we move to the question. So I'm going to stop sharing on this particular chart. We'll open the video back up. Hopefully you'll be able to see me, and we'll start to answer questions. So again, please, if you've got a question, open up the chat icon at the bottom of your WebEx screen, and then you can type in your question in that chat box. Hopefully I'll see it and we'll be able to respond. And got some that are already coming through. Let's see, this first one is from Lucy. And Lucy says, as we build a new system piece by piece, how can we avoid bottlenecks, conflicts with our current waterfall development and testing practices? Good question, Lucy. Hard question. When you're starting to transition, especially in a large shop, you are going to have some conflicts and there may be some bottlenecks. The key to minimizing those, I think, is in the selection of your starting points. And so I talk a lot about next week's episode, we're going to focus on this, but I talk about selection criteria when you are looking to start your transformation initiative. Your software delivery system team, people who are responsible for building your software delivery system and deploying that software delivery system and supporting it, initially are going to target a specific team, and they're going to do that in order to get the kinks out of that SDS and to make sure that it's working properly. But targeting that specific team or a team that can minimize the amount of interaction with other teams, other systems, will be very helpful. Now, I say that being in software business, and especially on the mainframe side for a long time, that may be hard to do because systems are so interconnected these days. But minimizing that as much as possible, I think will minimize the number of bottlenecks and conflicts with other teams that may not be leveraging Agile or leveraging the SDS initially. And so I think that's a good way to manage that. So it's in team selection and how you scale. And then as you bring more teams into usage of the SDS and of Agile or modern software delivery practices, hopefully you will have overcome a lot of those issues and bottlenecks, constraints in that scaling process. So next question, looks like from Gerald, and Gerald is saying, is revamping source code management the first step in the process? Ooh, Gerald, another hard question. And again, the typical consulting response is it really depends. Now, I won't run away from the question. And so what I would say is if it's not number one, it's definitely in my top three. And the reason that I say that is source control or version control typically is embedded in your software configuration management system. On the mainframe, it's going to be ISPW or whatever SCM you're leveraging. And the ability from an Agile standpoint, and particularly from a DevOps standpoint, the ability to automate activities within that SDLC, so much of that originates from the SCM. If you think about it, there are promotion activities, there are even before that assignment activities. There is the build process that's typically initiated and executed through the software configuration management system. And then after build, subsequent deployment, again, typically managed by that SCM. So it's a great starting point. Now, I've worked with other clients, and the starting point would be with the IDE itself, and it's hard to argue against that as well. The IDE is also another critical component in modernizing the software delivery system. One of the suggestions that I typically make with clients, and this holds true, is that in defining what that initial deployment of the SDS is, it's typically the IDE integrated with the SCM. And that becomes essentially the core or the minimal viable product that you deliver to your initial users. And I think that's because that those two are so tightly connected. There are other starting points, and the starting points for any organization will depend on where you are in your journey and what you're trying to accomplish. And so it truly is it depends question, but certainly the SCM and its criticality to software delivery and its integration with an automated delivery system makes it one of the top three, as I indicated, with regards to a starting point. So yeah, if not top one, definitely top two, top three. Okay, next question is from Matt. And Matt asks, you talk about incremental implementation. Matt must have been listening to last week. I appreciate that, Matt. But new processes, new tools, and organizational changes can't be done exclusively of each other, can they? Yeah, they can. They can. In next week's session, I talk about the implementation process, getting started. And in an incremental fashion, if you're adding capabilities, adding features incrementally, there will be some work that you can do that's not in alignment with maybe other organizational changes. And so the ability to modernize tooling actually can be done, and a lot of people would suggest, and I'm one of them, that it actually be done first. Any of you that have looked at the 10 steps to DevOps, which is an ebook that we provide, a document that we have lived by, and a document that guided how Compuware actually managed their transformation. One of the things that you'll see in there was the incorporation or implementation of modern tooling prior to the implementation of or the leveraging of agile processes. And again, the reason was to get developers comfortable with new technology, but under processes that they had some familiarity with. And that eased the transition into the new tools. I've seen a lot of organizations that will immediately try to implement Agile along with new technologies, and quite honestly, it can be challenging to do all at the same time. So I think doing this incrementally is the best way to move forward, and I think that adding, defining what that minimal viable solution or product is, rolling that out, solidifying, stabilizing that with your initial users, and then building on top of that, adding new features, new capabilities. It may start, as I indicated earlier, with an IDE, a new IDE, and its integration with an existing SEM or a new SEM that's more supportive of agile processes. Is a great starting point, but you don't want to stop there, and it's going to continue to change and evolve. After that initial implementation and deployment, a good next step may be to add better application understanding, program analysis capabilities, depending on what's critical to your organization. That could be a subsequent sprint. Another sprint to be added might be to improve unit testing through the inclusion of modern unit testing, functional testing, integrated testing technologies. And once that's in place and leveraged, and people know how to take advantage of it, and they're getting business benefit and they're getting value from it, and it's understood well, then a next step may be the automation of that work through a continuous integration server. Again, the steps at which you're implementing these changes or adding these new features, capabilities to your software delivery system are dependent upon what's needed within your organization the most. And we'll talk about ways to determine that in a future episode. But yeah, I think that incrementally is definitely the way to move forward. Next question is from Tara. Tara asks, what is some of the supporting technology for move to agile development and delivery? A lot of that, Tara, was I think part of that last response. If you look at the primary requirements of agile, meaning smaller increments, smaller batches, being able to define work that can be completed in typically a 2-week sprint, minimizing rework. These are all attributes of good agile software delivery management with regards to supporting technology. Again, the software configuration management is absolutely key to that. Now, another I think very important, especially for mainframe systems, because I spent a lot of time with mainframe customers helping them understand how to fragment work. That seems to be one of the biggest challenges in the enterprise space. Is how do we segment these very large, very complex, very tightly coupled systems into work tasks or stories that can be completed in a couple of weeks, and it is challenging. I'm not going to deny that. But program analysis type tools, system understanding tools, have been a huge benefit with regard to moving to agile. Not only do those type of tools provide very tactical benefits to programmers, but to product owners and architects who are building those backlogs based on some project requirement, that information can be very useful in the definition of stories because it's relatively easy to understand where your integration points are within that system or your connection points. You can start to segment work based on system boundaries within the architecture of the application. So the SVM, I think, is a critical agile supporting technology. I think program analysis is a big or another very beneficial supporting technology, and then last testing. And testing is so important. And again, being able to look at testing and how we tested in the past using traditional waterfall techniques is going to change. Leveraging Agile, we've got shorter time blocks in which to get work done. Now, hopefully the stories are aligned with those time blocks, but the ability to test in an Agile world is absolutely critical. And I believe in order to do that, to leverage Agile, automation from a testing standpoint is maybe the most important. Because we have got to make sure that the modifications, changes that we're making to these systems, especially these back office critical systems, is done quickly, but it also can't sacrifice quality. And so we've got to make sure that we implement not only automated test execution, but automated test provisioning, from a standpoint of standing up the environment and provisioning the data. And that means that we're also going to have to become smarter in the data that we're using. If we want to move fast, we're going to have to reduce the amount of data that we're leveraging in our test, but it can't be at the cost of quality. And so that goes back to a statement made earlier about our architecture. Code coverage can make a big difference in making sure that the test data that you're using to test provides maximum coverage. Okay, let's see. Next question looks like from Jeff. Jeff says, as we're planning a new system, especially leveraging existing processes, what's the best way to approach technical debt? And I'm assuming you're talking about technical debt within the software delivery system. And conceptually, it's no different than technical debt in any other business application. The question is, how do we leverage it, especially leveraging, what's the best way to approach technical? We approach it the same way, that it's approached in traditional application projects. And what most organizations are doing, what I've seen, and one of the things that I believe in, is that technical debt stories and work becomes a part of the typical project. And it's, I'll use a Southern word, it's whittled away. You continue to address it. It's a problem. And it needs to be addressed. From a software delivery system, you think about what technical debt is, and it could be, as we just talked about, it may be testing processes. In the past, again, we've got scripts and processes that we have leveraged that's typically utilizing very large amounts of data in order to test with. Well, it takes time to stand up those environments, test environments, and it takes time to execute those type of tests with that kind of scale. And so some would view those existing processes and scripts as technical debt. And so we got to get smarter in how we test and how we deliver code. And one thing that we can do is to get better, smarter about testing. That's just one example. There's all kinds of examples. If you think about work that's typically done to support software delivery, especially in older ways of doing things, there's over a 30-year period sometimes with some of these applications. There will be processes embedded not only in that code, but in the processes that we use to make modifications to that code. And we've got to evaluate continuously those processes to make sure that the work that has to be done, and again to ensure quality, is being done as efficiently as possible. Okay, next question from Todd. My company is looking to adopt Agile for our mainframe development. Is it better to get that established with our developers and gain some experience before looking to implement it for a delivery system? I think I've already touched on that, but I'll review it again. There's lots of ways to handle it. I've seen organizations start with Agile processes from a project management standpoint. They'll start with a small team or a team, educate those developers, testers on how to on the usage of those methods. And in a lot of cases, they will leverage existing technologies or existing tools to do the work, but under an Agile process. That can be difficult, especially on the mainframe side, where a lot of the tools that we're used to using were built to support the traditional waterfall process. And you see this a lot in the traditional or the legacy SCM. A lot of those SCMs were built with rules applied to support traditional waterfall. A classic example is the prevention of parallel development activities. In an Agile world where work has got to be segmented into smaller components, you may have multiple developers working within a large code base, and we've got to separate that out. A modern software delivery system will have an SCM that can support those Agile processes. And so I think that's critical. My advice, Todd, again, I don't want to overstate or be repetitive, but start with the technology, and because people using new technology, but with processes they currently understand, I think makes for an easier transition. But that's, it almost can be a religious argument with some folks, but that's worked well for the shops that I've been involved in, and it certainly worked well for us at Compuware. Okay, let's see. There's another question. Oh, here we go. How Compuware Topaz can help to extract the business rules from the mainframe assembler code. Assembler code, mainframe rules in business, and assembler code, not something that you see very often, but there certainly is assembler code that's available, or that is out there. With program analysis, not easy to do. I will need to check into that. That's one of those questions where you may have stumped me with regard. But what I'll do is I will respond in our compuware.com/goodcoding webpage and try to get you an answer for that as quick as possible. Let's see, this is from Chris. In your experience, what is the source of the most wasted development time to capture and improving software delivery throughput without compromising quality? And let me answer that one first. We did some work several years ago with regard to looking at the existing processes of developers, and primarily in a waterfall environment. And the number one consumption of time in that SDLC will surprise, well, maybe it will surprise you. It was in the time, non-software related time, meaning time required to manage other activities within the software development environment, meaning status reports, status meetings. The number was staggering. It was like on average 29-30% of measured time within a traditional waterfall project was spent in non-software producing related activities. And if you think about it, it makes sense. And so one of the things that I talk about in modernizing your software delivery environment is improved collaboration technology, so that all stakeholders within that software delivery lifecycle have access to the latest and greatest information, and we minimize or reduce or eliminate a lot of the time that we spend in defining status, capturing status, reporting status. I think that can have a huge benefit, and that, in my experience, that's been one of the things that consumes most of the time. So better collaboration tools, real-time collaboration tools, where you can eliminate the status meeting, the Friday status meeting or the Monday morning status meeting, is one of the biggest things you can do. And then there's a follow-up to that question. And in your experience, when trying to capture this most time wasted, how long does it take to make a meaningful improvement? Well, again, it depends on where that wasted time is. With regard to status tracking, status meetings, that can be reduced fairly quickly through the incorporation of better modern collaboration tools. And I see a lot of organizations doing that. I go to so many sites, or I've been to so many sites, where you've got the non-mainframe developers and testers are using tools like Slack and Jira and other tools to manage work activity and to provide reporting on status. And then in the same shop, you'll have the mainframe side of the house still leveraging, the traditional Microsoft Project and Excel worksheets to manage work, and that's where they track, and then they have recurring status meetings to talk about that status. So that's being able to find that time and move to or reduce the collaboration status tracking time can be done relatively quickly, because typically you can just transition tools that you're already using, maybe on the non-mainframe side, to the mainframe side, and start getting everybody to leverage those same technologies, and that will have a dramatic impact on overall cycle time within the SDLC, and it's something that can be done pretty quickly. Now, other wasted efforts, I was in a shop, and I was talking to a group this past week, and we were looking at their processes, and just their problem was the number of stories that they could actually complete in a traditional or typical sprint, and the number was very, very low. We started looking at the details as to why that was true, because there can be a couple causes of that. It can be improperly defined stories, or it can be just the sheer amount of cycle time for the execution of that story. Cycle time being the setup time and the execution or process time to complete that particular story. In this particular case, they were spending tremendous amounts of time in test setup. And I think that's fairly typical of what I've seen in a lot of organizations. And the sad thing about that is that it seems to be a repetitive work activity from project to project as we move through. So one of the things, being able to automate that provisioning of that test environment and the execution of those tests, if we can automate that, certainly we can save a lot of time. Now, there's a cost and there's some investment in building an environment or building an SDS that can support that type of automation. And so depending upon the complexity of your application and system will dictate the time requirements to build an SDS or a software delivery platform that can reduce that setup time and that execution time. But again, the time required to stand that up or to build that or to set that up depends on scale and complexity. And so let me see, I think there's one more question in that. So I'm trying to find a way to create a quick win to get transformational street cred with management. I think the key to that, Chris, is understanding their language, being able to provide an argument that is more business oriented than anything else. We as technical people tend to focus on the technical side and the benefits from a programming perspective or from a testing perspective or a deployment perspective, and what will resonate with the business is being able to articulate metrics that are important to them. What can we reduce the cost of defect management? Can we produce systems faster? How much faster? Those things are going to be important to them. And with regard to how to do that, I hope you'll listen to next week, because I'm going to talk about getting started. And in that, we'll talk about some of the key activities, or what I believe are the key activities in getting started in more detail. Defining that software delivery system team at an executive level, at a product owner level, at a team level with developers and testers who are responsible for that SDS. And then the other key thing as far as getting started and initial successes is managing scope of how that's deployed. And we'll talk about that, and I hope you'll join and listen to that as well. But all good questions, all great questions. It looks like I don't see any more at this point in time. So if not, we'll wrap up. Again, I appreciate very much those of you who joined us. I hope that this is informative. As we move through the podcast series, initially we talked about, what's good software development, what's a modern software development environment look like. We then talked about what's the basic architecture that can support a modern software development environment. I did that with Dave this week, and we talked about what I've seen, what Dave's doing here at Compuware. Next week, we're going to focus on getting started and how to get started, how to obtain those incremental wins. And then after that, we're going to dig into the architectural components, or the technologies that are needed to support an agile and a DevOps-centric software delivery environment. And I hope you'll join us. It's getting fun. We're going to get deeper and deeper as we move through this. And again, I'm enjoying it. It's different. I got to say, I've spent my career going to clients and talking to them about these issues, and specifically what their particular issues are and what their problems are. And I've always loved it. I love this work. I love what I'm doing. Doing it to a camera is a little different, but I'm starting to get the hang of it, and I appreciate you joining us. Next week, I'm going to take a little time off. I have vacation days scheduled, and I'm typical with a lot of you, I suspect, and I've got a group of guys that I've been doing this for 40 years, college buddies, and so we're going down to play a little golf down to Myrtle Beach next Thursday and Friday, playing a little tournament. So going to be away next Friday. We will drop a podcast that I talked about on getting started, but we'll respond to questions through the next live Q&A, which will be on the 29th of this month. So we'll respond to those questions at that point in time. If you've got burning questions that you'd like to get responses to, absolutely send me an email, again, at rick.slade@compuware.com, and I'll respond to you personally, and we'll go from there. That's it for today. Again, thank you for joining. I look forward to meeting with you again on the 29th. Again, we're going to do it. We're going to drop another podcast next week, so I hope you'll listen to that. But with that, please stay safe. Have a good weekend, and good coding, everybody. Take care.